Action. Good. All right, at the top of your notes, today we're talking about analyzing exponential functions. This is kind of a prep to 2.5.1, so all the classwork and homework are on the iMath document, because I want to really just look at one little part of this to start. So the first part is just a review that's going to be helpful for the SATs, for all your classes moving forward with math. And really what this review is, it's converting between a decimal, a percent, and a fraction. Okay. So I'm sure a lot of you know one way to remember this or another. There's rules you can remember to go between. But we're going to use this key example to recall the process even if we forget. So like if you're walking to my class and you forget which way it is, you go down the wrong hallway, that kind of thing, you just forget. That didn't happen to anybody. It's first day back.
Oh, yeah.
So anyway, I want you to use this key example to recall this process if you forget. Okay, we're going to think about, you have 50 cents in your pocket. Okay, you have 50 cents. So 50 cents, how much of a dollar is that? What's my percentage of a dollar if you have 50%? 50 cents. 50%, right? Okay. Now, if you have 50 cents in your pocket, what's your fraction of the dollar you have? What's a fraction?
Half.
1/2. So if you remember this, if you go back and you say, okay, I need to remember the process for going between decimal, percent, fraction, think of 50 cents. 50 cents is 50%, which is also half of a dollar. Okay, because that's something really easy to get our head around, and from there you can deduce all the rules to go between them. And I did put the rules, the hint down here. To go from 50 to 50%, all you have to do is move the decimal 2 places to the right. It's really just multiplying by 100. So we move it 2 to the right, even if it's a whole number. So even if we have 1.25, if I am going to convert this to a decimal, a percent, I'm going to take a decimal, move it twice to the right. So then I'd have 125%. So in this case, we will have percentages that are over 100%. That's fine, because with decay and growth, if we have some growth, it's going to be more than 100% because we're getting more out of it. Okay. So looking at this, that's how we get to percent. To go from a percent to a fraction, we're just dividing by 100. Take that percent value, 50, divided by 100, and you can reduce that. 50 is easy to think about because there's 2 50s in 100. But if you didn't know, if you had a weird one, not weird, but if you had, let's go with 84 over 100. Right. If I need to reduce this, I just have to remember they're both even. So I can reduce it by dividing by 2. They're both even still. I can divide by 2. And that's all we can do. 25 is 5 and 5. There's no common multiples to divide out. Okay. So when we get down to this step, remember we're just putting over 100 and we're just going to reduce. So how about this? 0.32.
32.
Go ahead and put the percent on your own and then change it over to a fraction. And let's see if we can get both of those 2 values here. Good. Already done with both? Yeah. Okay. Good. Yeah. All right. Jason, help me out.
Yes.
Okay. 0.32 as a percentage.
32%.
Okay. That one's the quick one. All right. How about as a fraction?
32 over 100, which goes to 16 over 50, which goes to 8 over 25.
Nice. Yeah. All right. How did you know to stop at 8 over 25?
Because you can't simplify 8.
Right. There's no multiple that goes into 8 and into 25. So we know we're done. Perfect. All right. 0.9. I think we get this, so I'm going to do it along with you right now. 0.9. How about as a percentage?
30.
How much?
90%.
32.
I heard 32%. And I'm not even sure how to approach that.
I don't know. That's a crazy for someone.
All right, so we have 90%. How about as a fraction?
9.
Okay, it's 90 over 100. We divide by 10 both, so we get 9/10. Okay, everyone feel pretty comfortable with this? Okay, for the process we're going to be dealing with growth decay, we're going to go between the decimal and the percent. We won't have to use the skill of going to the fraction for today, but I just want you to have, these are the three forms, so I wanted to go through all three of them. Why go through two? We have three, we'll do all three. But what I'm saying is, today we're really just focused on go between percent and the decimal. All right, so this is new. This is the new part for today. It's a kind of a smaller part to get through compared to tomorrow and Wednesday. But we're looking at, first, the growth and decay factor. The growth and decay factor, you're always going to be given this amount. You're going to be given that value. Okay. And what we're talking about is, well, first it's usually represented as a fraction. I want to change that. Erase fraction. It's represented as a decimal. All right, so it's represented as a decimal. It could be 1.25, so it could have a whole number out in front, but in general, we're talking about a decimal. It's the amount of growth and decay over time. So if your growth factor, actually, I'm going to give this analogy down at the rate. But the growth factor is just talking about how much growth or decay over time. So it can be a positive amount, positive growth, or it could be a decay. What we need to do is convert, go between the factor which we're given, we have to find the growth decay rate. Okay. And this is the amount of growth or decay per time period. So it could be per week, per year, per day, per hour. And you can think of this as, if you invest in stock, and you have a 12% rate of growth. If you put in $1,000, you end up getting out $120 per time period. So maybe it's per year. Okay. Decay would be if you buy a car, once you drive it off the lot, it has a certain decay in value, and each year it keeps losing value. So that's just the concept of what we're talking about. There's going to be a rate that either increases the value or decreases the value. All right. The way that we figure that out is just taking the growth decay factor and we just subtract 1. So let's use this example up here. If I had the growth decay factor, which is going to be given, and it's 0.54, to find the growth decay rate, I take 0.54 and I subtract 1. Okay. This part, you're going to start to see some easy ways to figure this out. 0.54, one way to think of it is, if I had 0.6, it would be 0.4 to get up to 1, right? But then I have, to get to 0.6, it's 0.06 to go up. That's a horrible way to explain that. Sorry about that. Basically, this is okay to start if you use your calculator. I think you'll get the mental map on how to get to that answer on your own. Okay, so however you think about it, we're going to end up with negative 0.46. All right. So looking at that, now we'll go to our second point here. Once you have the rate, it's negative 0.46. Right? We know it's a growth rate. It's a growth if the rate is positive. So we have a little happy smirk. Down here, if the growth is negative, we have decay, and it's a little sad smirk. They're both kind of happy. Downward facing smirk? I don't know. So looking at this right here, we have a negative rate. So do we have growth or do we have decay?
Decay.
Decay. So I'm going to circle decay down here. And then if we're looking at the growth decay percentage, this value is going to be completely connected to if it's decay or growth. So we're not gonna put this negative value in here. We're gonna just go ahead and convert this to a percentage, 46%. So from this, I was given the growth decay factor. I subtracted 1. Negative 0.46 tells me it's decay. Change it to a percentage. Now I know I have 46% decay. 46% decay. Okay. If you forgot to label if it was growth or decay, that's an incomplete answer, because it is 46%, but then I have to know if it's decaying or growing. Okay, so this is, in this case, decay. So for the classwork and homework, you're going to be recreating a table that I put in the iMath doc, and basically each column is going to have a separate component here to figure out. So we will try a couple on our. All right, here we go. How about 0.25? Let's try this on our own. Go ahead and find the growth decay rate from 0.25. What am I going to do with 0.25? I'm going to good. And if you want to use technology to do that -1 real quick, that's fine. Oh. So we have 0.25 for our growth decay factor. That's what's given. We need to get down to the rate right here. So somebody just tell me, what's the process? What do we do with that 0.25? Subtract 1. 0.25 minus 1. So you have 25 cents in your hand. You owe someone $1. So how much are you short?
75.
Negative 0.75. Do I know about growth or decay? Is it growth or decay?
Decay.
Okay. What is 0.75 as a percentage?
75%.
So I know that when I'm given this growth decay factor, I end up with 75% decay. I end up decay. So that would be losing a lot of value on your car. Maybe that's after a decade. You lose all that. All right, how about this one? 1.09. What's my step to find the growth decay rate? Oh, that's better. Yeah, I like this. Let's see what we're going to do. You have $1.09. You give someone $1. How much do you have left over?
9.
Okay. Is this positive or negative?
Positive.
Positive, so I know I have some growth. What is 0.09 expressed as a percentage?
9%.
9%. Okay. See how we're setting these up? So this is just one little component of what we'll do tomorrow. We're gonna basically input this step into a larger formula to find some actual values. So you actually plug in how much your car is worth, if you have a car. All right, how about one more? 0.56.
Wait a
0.56.
Negative. Isn't it negative?
Negative what?
No, but that's numbers.
Negative 44.
44? Negative.
Point.
There we go. All right, negative 0.44. Growth or decay?
Decay.
Good. Decay?
44%.
44%. All right, thumbs up, sideways, down for these process. You guys are ready to go, huh? You guys are ready. All right, let's do a post Thanksgiving break. Maybe whisper subscribe. All right, 1, 2, 3. Whisper subscribe. Subscribe. What'd you say?